Now we see that the slope has been calculated over a fairly wide interval from 10-second to 30-second clock times. The slope is changing over that entire interval. The slope keeps decreasing as we go down. What we're really after is the rate of change at the t equals 10-second instant. And this rate between the t equals 10 and t equals 30 second, the average rate between these two times, isn't going to give us a real good determination of the instantaneous rate at which the depth is changing at that 10-second clock time, at the instant the clock reads 10 seconds. We could calculate the slope over a shorter time interval, indicated by this small triangle here, and see if we don't get a better result. Well, if we go from 10 seconds to 12 seconds, let's say, substituting tells us that the depth goes from 80 centimeters to 76.36 centimeters, a change in depth of negative 3.64 centimeters over a 2-second time interval. This gives us an average rate of depth change of negative 1.82 centimeters per second. The delta y over the delta t is negative 1.82 centimeters per second. It makes sense that we would get negative 1.8, we would get a greater negative number. Remember, here we got negative 1.55 centimeters per second. If we take the shorter interval, the graph is really steeper over this interval because the graph is becoming less and less steep. So that if we got a negative 1.55 here, getting a negative 1.82 for the shorter time interval makes perfect sense. Now we could continue taking shorter and shorter time intervals and get a pretty good idea what the rate of change is at the clock time t equals 10 instant. However, what we're going to do is we're going to symbolize the process a little. Instead of talking about clock time 10 seconds to some specific clock time, we're going to say the clock time goes from 10 seconds to 10 seconds plus delta t, where delta t is not specifically determined. You see that we'll get a slope triangle with a run of delta t, but we don't know what to put in here for the depth. Once we have that, we can proceed to evaluate the slope.